Alright, I want to address a very important topic in mathematics, and one that usually will give students fits until they can develop the mathematical maturity to understand it and reason through the implications. So, logarithms help us understand how to answer questions like, what power on base 3 gives 9? So, we try to write this in a mathematical way with no words, and one way that we might do it is say power on a base of 3. So base means low, maybe, so we might use the 3 as a subscript. So the power on base 3, power subscript 3 to give 9. So the power on 3 to get 9 might be a shortcut way of writing this. So by definition, if we raise 3 to this power, whatever it is, we don't know what number is represented by that just yet, we would get 9. So, what power does this have to be? Well, since 3 squared is 9, this thing, this function, this number, is 2. So the power on 3 to get 9 is 2, because base 3 to the second power is 9. Okay? So it's very important to understand all of this. You may need to pause and replay it, write yourself some notes about what this means to fully understand all these things. Now, the next part of this is, what does this have to do with logarithms? Well, logarithms were created, if you want to call it that, by someone named John Napier, and he didn't use the word power, he used the word logos for this, and so the abbreviation for that was log. Logos has some translation, I think meaning ratio or something. So instead of the word power, we use the word log. With a base of 3 gives 9 is 2. So this is the same thing as writing this. I recommend for a while, if you see an expression like this, rewrite it with the word power in place of log so you can start to understand its meaning. And then once you get proficient at going one way or the other, just write log. Okay? Now the way this is read, this is a function, and the function here is this part of it. Okay, so how do you read this? We don't say the power on 3 to get 9. We say, now in this notation, log base 3, that's the function part, of 9. So it's like f of 9. So you might have, let me get rid of this circle here. It's like log base 3, that's your function, of 9. So every log has a base. So that's the function of 9 is 2. So f of 9 is 2, basically, is what we've got, and f is log base 3, that particular function. So log always has a particular base to it. Alright, we don't write the parentheses here typically. The other thing is, this number that you take the log of many times has a name, and it's called the argument. Alright, so we have log base 3 of 9 equals 2. That means the power on base 3 to get 9 has to be 2. Okay, so the function here is log base 8, and I'm taking the log base 8 of 1. In other words, I'm asking myself what power on base 8 gives 1. Well, 8 to the 0 power is 1. So log base 8 of 1 is 0, because that's the power I have to raise 8 to get 1. In general, almost any number, let's call it a, to the 0 power is 1. So that means log any base a of 1 is 0. Alright. Here I'm trying to find the power on base 5 to get negative 5. Well, we're comfortable with exponents, should be comfortable enough with exponents to know that if I raise a positive number 5 to a power, I'm never going to get a negative number. So that translates here to the argument of a log shouldn't be negative, right, if we have a positive base, and we'll always work with positive bases. So the argument of a log shouldn't be negative. So keep that in mind for later when we look at logs as functions in general.